Today we're coming to you from Playa del Rey, and we're here at the Los Angeles Department of Water and Power's Scattergood Generating Station. With the cooperation of the people who make this place go, we're going to show you just how the lights are kept on in Los Angeles. All of this and more right after the credits. Hi, and welcome to Newswire L.A. I'm your host, Chin Thomas Sangsi, and today I am coming to you from the Scattergood Generating Power Plant here in Los Angeles. We are here today to see a new and exciting repowering that's going on inside the plant. What's going to happen right now is that one of the turbines, Turbine 3, is going to be changed to a newer piece of technology which will be much more clean burning and friendly to the environment. It'll also generate more power for the city of Los Angeles. We're going to go inside and we're going to show you that, and we're also going to show you the general plant operations. This is part one of a two-part series coming from Scattergood. Before you can understand the importance of the Scattergood Generating Station and its upcoming repowering project, it's necessary to understand the city of Los Angeles and its constant power needs. As you can see from these images, we consume a lot of electrical energy. The city of Los Angeles covers an astounding 465 square miles, with a total population of 3.9 million residents. Of those 3.9 million residents, 1,461,344 of them are registered power consumers. According to a 2010 study from the Los Angeles Department of Water and Power, Los Angeles, at its peak demand, consumes 6,142 megawatts of power. Now keep in mind that we're talking about electricity needed to power residential homes, commercial businesses, and industrial plants. Under Ezra Scattergood, the newly named Department of Water and Power kept pace with rapid changes and growth in the city by constructing new facilities and going after new energy supplies. However, in doing all of that, he stuck to his guns that the power had to remain low cost to stimulate industrial expansion. Scattergood remained with the Department of Water and Power for 31 years before moving into the Roosevelt administration due to a committee appointment. Scattergood died in 1947, and the facility you're looking at right now was named for him in 1959. Now, that's as far as I want to go with the history of this facility located in Playa del Rey. For the operational aspects, I'm going to turn it over to our first of several guests. For this broadcast, we're going to rely on two main players. The first is Ralph Payne, who is the supervisor of operations here at the Scattergood Generating Station. Backing up Ralph on some issues will be Jose Gutierrez. Jose is the project manager overseeing the Scattergood Unit Number 3 refit. First up, Ralph Payne. All right, and I'm here with Ralph Payne, supervisor of operations for the Los Angeles Department of Water and Power. Ralph, thank you for joining us.
Thank you.
All right, Ralph, you're going to give us the big story. Can you give us a basic history of the Scattergood Generating Station here in Los Angeles?
The plant was built in 1958, Unit 1, and Unit 2 came online in 1959 and produced about 370 megawatts. And then in 1974, Unit 3 came online and added an additional 460 megawatts. And that's how the plant has been built.
Now, 370 megawatts translates into how many homes being powered?
Roughly 370,000. There's about 1,000 homes per megawatt. Yeah.
Okay, so that was 370,000 at the time it opened in the 50s. By the 70s, you had added 460. What's the overall power generation of this plant?
About 830 megawatts. Yeah.
I realize that I believe it's turbines 1 and 2 that are original equipment from when this place was built, correct?
That's correct. They were built in 1958 and 1959. The equipment usually is designed to last for about 30 years. That's the design point for these units. But we've been maintaining them and taking care of them and rebuilding them and stuff to keep them lasting for the 55 years that they've lasted so far. Yeah, they're extremely reliable.
Are parts readily available, or do you guys have to mill the parts here and put them into the system?
Many parts are available, and what's not available we have to make up ourselves.
Can you give us an idea of the areas that Scattergood covers?
The transmission system is an integrated system, so it's like a loop that goes throughout the whole city, and we just apply power into that loop. We apply it to two places. The Scattergood airport lines go to the airport receiving station, and Scattergood Olympic lines go to the Olympic receiving station. But they supply power to all of L.A.
And one of the things that was very interesting that we talked about the other day, and I'd like for you to repeat it to the audience here, is despite what many of us think, and I came in here thinking the same thing, that LA's Department of Water and Power was from border to border, from the border of the city, and that was it. But you were telling me the other day that there are redundancies built in that also include other utilities, that we rely on other utilities as well to keep the grid going. Can you talk a little bit about that?
Yeah, the power grid is really everything, everybody's power system from this side of the Mississippi all the way to the West Coast, and we're all tied together as one grid. So if any part of the system goes down, the remaining system will pick it up, and that's to increase the reliability through the whole system. But we have transmission coming into our system from all over the place, 5 western states. We've got coal plants in Utah, we've got nuclear plants in Arizona, we've got solar and wind power plants as far away as Utah and in the Mojave Desert and all over the place. So our system gets power from all over the western United States.
One particular question has been on our minds. That question revolves around why the LA Department of Water and Power has generating plants in cities outside of the Los Angeles city limits. Here to answer that question is Jose Gutierrez. And I'm here with Jose Gutierrez, the project manager here at Scattergood Generating Plant. Good morning.
Good morning.
The LADWP has plants like this plant, Scattergood, but they have them in different geographic areas of the city. And some of them are actually outside of the city's boundaries. What was the logic behind that? Because the power, from what I understand, is being consumed by the city of Los Angeles itself.
We have some power plants located outside of the city because of the necessary infrastructure to incorporate those plants and bring the power to the city. For example, we have transmission lines throughout California, and we try to locate power plants near those transmission lines. Also, we have 3 coastal plants, and the reason they're located there are to use the ocean for cooling and converting the steam into water.
Did you know that there are 3,656 miles of DWP transmission lines crisscrossing the city? There's another 6,793 miles of overhead lines and another 3,547 miles of underground distribution lines. It takes that kind of infrastructure to keep this breathtaking image you're looking at right now. Without it, you're going to get a whole lot of this. Now here's what you've been waiting for. We're about to begin our tour of the Scattergood Generating Station. Remember, On this broadcast, we're emphasizing what we have in operation today. But once we head outside, we will show you many images of the plant repowering underway. Here's the main area housing generator units 1 and 2. But our showpiece is this metal grate our camera operator is standing on. You're staring about 3 stories or more down to sea level. What you're looking at are the pumps that send ocean water in and out of the generating station. Let's take a look outside. Here we are in Dockweiler State Beach, which is on the west side of Vista Del Mar. You can see the ocean right here, but watch as we pan due south. Coming into view is a facility that belongs to Scattergood. It is here that water is processed before moving to or from the Scattergood generating station. And here you see the generating station where all things happen. Here's a final parting shot of the area 3 stories or more below us. Now let's get off this grate. And here's an image of the outer wall of one of Scattergood's control rooms. The sign you see that reads Communications and Control is actually a leftover movie prop from a classic film that was shot here many years ago. If you can guess what it is, let us know on Facebook or Twitter, and we'll tell you if you're right. Nevertheless, the crew liked it, and it's been here ever since. Join us inside of the control room here at Scattergood Generating Station. Here we are in Scattergood's control room. Take a look around. Camera, give it a sweep. Take a look at some of the indicators on the wall. Some of those indicators are leftovers from the 1950s when this particular plant was built. In fact, most of this is actually an integration of technology from different eras into today. Camera, take a look over here very quickly, if you would. Now, you're taking a look at some of the levers. Some of those levers are, from what I understand, air pressure operated. From what I'm told by Ralph Payne, these are actually far more reliable than some of the more modern controls we use today. Camera, take a look at this monitor on the wall. Ralph Payne, can you give us a quick rundown of what we're seeing on these 2 TV screens?
Yeah, those are the burners. There's 20 burners. There's 16 burners on this unit. They're about 30 inches in diameter each, and burning natural gas.
All right, and these cameras are on 24/7, right?
Yes.
All right, these are the natural gas burners being watched from right here in the control room. All right. These are some of the printouts, and not a lot of us have seen this kind of paper in many years now that we've gone to LaserJet, but they're still using the paper with the graphs and the little holes in the side, and I forget what it's called these days. You can see other indicators over there. Like I said, it's a mix of technology from different eras. You see some of the modern displays, and you see some of the old dial displays from the 1950s, 60s, and so on. Ralph, you tell me that once a lot of this equipment is decommissioned, it's going to go into a backup status, right?
Once it's decommissioned, it's actually required that it be made unoperable. So we actually have to either put slurry in the gas lines or something to make them so that you can't start them again.
Okay. We learned an interesting fact while researching this story. We learned that digester gas from Scattergood's next-door neighbor, Hyperion sewage treatment plant, is piped in and used to power this plant's generators, thus giving us power in the city. Jose Gutierrez explains the process, and Ralph Payne will show us the apparatus used to make this happen. And right next door to us is Hyperion Sewage Treatment Plant. That does a whole different function than what this plant does, but I understand there is some interaction here with the Hyperion digesters. Can you explain that process to us?
Yes, Jen, there is some interaction between the Hyperion plant and the Scattergood currently. Currently, Scattergood takes some of or all of Hyperion's digester gas, blends it with natural gas, burns it on our either unit 1 or 2 to produce electricity and steam. That electricity and steam, some of the steam is sent over to Hyperion to use in their digestion process.
These are the digester gas scrubbers. They're filled with activated charcoal, and they take the siloxane and benzene and hazardous chemicals out of the gas before it goes into our boiler.
And this is part of the substances that come over from Hyperion that are mixed here.
That's correct.
All right, and we're out here on the back of the Scattergood plant. What are we seeing going on out here, Ralph?
Well, they're in the process of drilling the piles for wall 1, the retaining wall for the combined cycle unit. And this is the drill rig here that's finishing up the last pile, and they're just getting ready to tear it down and move over to wall 2, which is on the southern end of the property.
And I'm seeing that this giant crane over here has a really, really big drill bit on it. That's the one that's drilling the piling, right?
Right. They drill probably about 70, 80 feet deep, and then as they back the drill out, it gets concrete pumped into the hole so the hole doesn't collapse, and then they drop a metal H-beam down in there.
And what's this pond down here?
That's our settling basin C. It actually is in use now. It's drained all the way for right now, but it's still an active settling pond.
Now, from what you told me the other day, that pond will be moved and will be placed elsewhere during this construction phase, right?
Right. Currently, it's scheduled for demolition on Monday.
What is the purpose of that particular pond?
It's to receive the drains from the boiler and stuff when they're starting it up, and the blowdown from the process of operating a boiler.
You have two storage tanks filled with water that can keep this power plant going, even if the city water supply is cut off for any reason. Give us a little bit more about that.
Right. We have 2 service water tanks. I believe they're 1.5 million gallons each to give us somewhere in the neighborhood of 30 days worth of water in case we have to do without water from the city. We also have a condensate tank that's about the same size for the pure water.
That area over there where we see all the high tension lines, I'll call them in layman's terms. You can tell me what they technically are called, but are there any changes going on in that area we should know about?
Right. That's the 138 and 230 kV switch rack, so 138,000 volts on the north side and 230,000 volts on the south side. And the 230,000 volt system is where the new combustion turbines are going to be tied in. So we're adding new positions onto the switch rack down on the south end of that.
And one thing that we have to tell most people is that this stack that we're looking at right here on Unit 3, once the repower goes in, it's not going to be here anymore.
That's correct. We already have engineers working on the demolition plan for this, and we already have other engineers working on the repower for units 1 and 2, which will go in that unit's place.
As we said the other day when we were here, this plant, strangely enough, is kind of a landmark for this area. A lot of people are going to be missing seeing that one tower.
Right. These stacks are kind of a landmark that everybody uses to navigate by. So it's, I don't know what.
But unfortunately, they must go.
That's true.
Scattergood was an electrical engineer who worked on the power end of Los Angeles' Owens River project. As he worked on these aqueduct projects, he realized that Los Angeles' future rested upon the availability of low-cost water and power. Under his direction, hydroelectric plants were built along the Los Angeles-Owens River aqueduct. These plants allowed what was then known as the Bureau of Power and Light to buy out most of the private suppliers and later acquire the Southern California Edison distribution system. Now that we've wrapped up our look at the current Scattergood generating station, we're going to take the first step into our look at the power refit of unit number 3. Our next broadcast will dive deeper into this project. Let's welcome back Project Manager Jose Gutierrez. We're actually aware that government mandates and some environmental concerns have necessitated part of this repowering of Scattergood. Could you talk a little bit more about that? Give us the key bullet points behind this whole project.
Sure. Some of the constraints and government mandates include the elimination of ocean water for cooling, improved efficiency, and reducing emissions. So for example, this project here, we're going to have a dry cooling system, which is basically a radiator, and we will not have to use the ocean for cooling with that system. This technology is a lot cleaner and more efficient. It uses a combined cycle, which makes this equipment consume less fuel for the same amount of power that's produced from the current equipment. Also, this equipment will be allowed to cycle more frequently, so we can turn the units off at night when power is not needed, and having less emissions throughout the day that way.
Give us a quick rundown of the process that's taking place at this very moment to repower this plant. I understand it's turbine number 3 that's actually starting the whole process. Give us an idea of what's going on inside.
Yeah, that is correct. We're going to be replacing our Unit 3 steam generator. And part of the process first is to improve the site to allow the new equipment to fit on the site. Here at Scattergood, we have a small terrace site, so we have to do a lot of work up front, a lot of civil work to enlarge the site to allow the equipment to fit. So that's what you can see behind me, what's going on. There's a lot of wall constructions that have to be built, and once all the site is developed, then the equipment, the large major pieces of equipment, will be delivered, and they'll be located on their foundations, and then all the electrical and mechanical connections will be made, and then we will commission the equipment and test it and start it and hopefully energize it and put it on the system.
And ultimately, what's the estimate date of completion for this entire project?
The estimated date of completion for this project is December 31st of 2015.
Here's the big question. With this refit, what can the Los Angeles citizens expect to get? Cheaper bills, better energy? What's going to be the benefit that comes out of this entire repowering?
Well, with this repowering, the ratepayers from the city of Los Angeles can expect many good things, such as improved reliability of the power system. We're going to replace aging infrastructure with brand new advanced technology. This technology will support DWP's goal of 33% renewables by responding very quickly and much faster than the conventional old equipment that we have. Plus, we have environmental benefits. We're going to be eliminating the use of ocean water for cooling, and we're going to improve efficiency in consuming less natural gas, which will result in less emissions to the environment.
All right. Jose Gutierrez, thank you for joining us.
Okay, thank you.
And here's what you can expect on our next Newswire L.A. broadcast, coming to you from the Scattergood generating station in Playa del Rey. You've got this map behind us. What's the significance of this map?
This is the Scattergood where we're standing right now. And from here, it goes at 230,000 volts underground. You won't see it after it's done. You will not be able to see anything, but it's there. It goes through these maze of streets and will land up here, which is what we call receiving station K. And receiving station is a place where we get high voltage, 230,000 volts, and through transformers we lower the voltage and we distribute it along the city. In addition to that, this will serve as a link to the valley, transmission link to the valley, so we can exchange power between the south side and the valley. because some of our transmission come from the north.
Now talk to me a little bit about what it's like. You're kind of the big guy holding on to all of these large projects. What are the difficulties in managing large projects like this?
Well, the first thing is safety, and we want to make sure, even as we're wearing our hard hats today and safety equipment, to make sure that our employees are safe. There's a lot of equipment, as you'll see, and as you've covered in your footage here on this job site. And so safety is number one, and making sure that our employees are safe during the workday. And then secondly is just a lot of logistics. We have a lot of material that will be coming into this site from all over the world to provide us with this new state-of-the-art generating equipment. So there's a lot of logistics. But the good thing is that we've got capable employees and contractors that are knowledgeable, engineering firms that are helping us in getting this job done.
And these casings right here, I see they're built above ground. Do they have to be lifted in ground, or are they built down in the trenches once you dig them?
No, they're built up top, and we basically skid them over to the excavator. Excavator has a special set of bridles you see laying on the ground right there. We'll reach over, pick them up, set them in, and excavate throughout the inside of them.
And that's it for this edition of Newswire L.A. coming to you from Scattergood Power Plant in Los Angeles. We hope you've enjoyed what we've shown you tonight and hope you have a better understanding of what the Los Angeles Department of Water and Power does for us each and every day. To follow more of Newswire L.A., look us up on Facebook and Twitter at Newswire L.A. And that's it. I'm your host, Chin Tom Sangsi, saying so long, and we'll see you back here next time. Stay tuned for more news on this Westlake Signal station.